You guys are on text page 274, blue notebook page 338, technically part 2, because of that mess where the numbers are different. So it should say lesson 6.2 at the top of the page, okay guys? What we're going to do today is in your textbook, we're supposed to go through 6.2, but we're going to combine it with 6.3. I feel that you guys can pick this all up in one lesson. That way we can get to the harder stuff and spend more time on it. So, very first question, example 1 on page 275. It's in your text, page 275. Solve for x. Check your answers by substitution. We're going to solve for x, and then we're going to connect it to 6.3's lesson. So this is going to be a longer lesson today, so make sure you guys take notes. In order to solve for x, we're going to do this by factoring. So we all remember factoring. It's the one where you guys are doing most of your makeup questions. In order to factor this, we take the factors of a and the factors of our c, which are 1 and 14, 2 and 7, and we know that the products have to add up to positive 9. So, from quick glance, I can tell already we know we're going to be using that column, and I know I'm going to use this column. 1 times 2 is 2. 1 times 7 is 7. 2 plus 7 is positive 9. Works out excellent. We go to put it into our brackets. Now remember, this is what's very important. I guess I'll put it on the other side. Let's finish our brackets first. So, in our brackets, we know we're going to have 1x. So I'm just going to write it as x. And the other one will also be just x. Our two other terms technically have to go into opposite brackets of what we multiplied them by, but luckily they're the exact same number, so it doesn't make a difference. So I'm going to get positive 2 and positive 7. Now, I did all this factoring here underneath. This technically isn't part of our equation. This is more like a side calculation. So really, I went from this line of the equation here all the way down to here. This is technically our second line. Oops. Second line in the equation. So, when I bring down an equation, I still have to bring down the equal sign, and this is equal to 0. This is very important. Make sure you still have equals to 0. The idea here now is, I'm going to try to simplify this a little. Think of each of these brackets as one number. We don't know what that number is. We know eventually they're going to equal one number. We also know that this side of the equation is equal to our 0. So in order to make a 0 by multiplying, because these two brackets are beside each other, so we know we have to multiply, what would I have to multiply to get to 0? 0. So one of the brackets is going to be equal to 0. I know that. Okay? So, since I know that one of these are going to be equal to 0, I'm going to actually solve for both of them. What's going to happen is we're going to get two answers. So I'm going to split this. I'm going to set x plus 2 equal to 0. And I'm also going to set x plus 7 equal to 0. So what I've done is I've taken each of the brackets and set them equal to 0. I'm going to end up with two different answers. In this one, x will be equal to negative 2. And in this one, x will be equal to negative 7. So, I've added a graph to this. The scale is just by 1s. How we're going to connect this to the graph is that what I've actually found, so x and our y-axis, what I've actually found are the two x-intercepts. So, one of the x-intercepts is negative 2, and the other x-intercept is negative 7. So I've actually found two x-intercepts from our quadratic equation. Okay? Now, with our two x-intercepts, if you guys remember, we can graph the rest of this. I can find out the vertex, or we call it the axis of symmetry. Does anyone remember how I find the axis of symmetry? Okay, yeah, so we're going to call this R and this S, okay? And we had that little formula, r plus s divided by 2. That's going to give us our axis of symmetry. So, let's solve this right now. That's going to give us -2 plus -7 over 2, which is equal to -9 over 2, which is equal to -4.5. So we know the axis of symmetry. I won't be able to draw it amazingly, but it's going to be roughly there. Ah, nuts. I don't know what happened, but we're going to leave that. Okay, so we now have our axis of symmetry. And that also tells us something about the vertex. Does anyone remember what it tells us about the vertex? Yes. For our vertex, we now have the x-coordinate. So we need our 2 coordinates for the vertex. Our x-coordinate is -4.5. It falls on the exact same spot as the axis of symmetry. Finally, I need to find my y-coordinate. So I'm going to take my -4.5 and I'm going to plug it in. Luckily, I can plug it into either our standard form or I can plug it into our factor form. It actually doesn't make a difference. What I'm going to do is I'm going to plug it into our factor form, because if you guys remember, we'll get the same number, plus and minus. So let's take a look at this. Let's take our factored form. We had 0 was equal to x plus 2, x plus 7. I'm going to substitute my -4.5 in for both of the x's. Sorry, I shouldn't say 0. We need this to be our y in this instance, okay? We're trying to solve for a point y. We're going to substitute this in. So our y is equal to -4.5 plus 2, -4.5 plus 7. Okay? So we're looking for what our y is going to be equal to. We're going to follow BEDMAS to solve this. -4.5 plus 2 is -2.5. And -4.5 plus 7 is positive 2.5. So now we know, remember I told you you're going to get the same unit with a positive and negative number, so the same amount. That's going to let us know that we are at an axis of symmetry. So that's the kind of a little trick there. And we're going to quickly multiply those two. Who can help me out with that? Negative. So it becomes -6.25. And that, remember it says y equals -6.25. So that is our y-coordinate for our vertex. Our vertex's y-coordinate is -6.25. So obviously it doesn't fit nicely onto this graph, but let's try to get it in. -6.25 is probably about there. Okay, so now that I have that, I can graph my equation. I start at my let's try to do this with that parabola. There we go, that's about right. There's our parabola now. We have our vertex. Our vertex is here, and we solved that from our factor form. And when we were solving for the x's, those were the 2 x-intercepts. And normally, it's important that we let whoever's looking at our wonderful work know that this is a continuous line. So I'm just going to put 2 arrows at it. It's going to continually keep going up, up, and up. So just to make sure that we have it right, we know that our A here, our A is a positive 1. So because it's positive, it's going to be opening upwards, which is exactly what we've drawn. So we have the proper parabola we've drawn. There's a lot of steps to that, but it's essentially what we need to be doing this. Guys? Okay, so for the next 5 or 10 minutes, I want you guys to turn to your blue notebook, page 342. Now, that page says solving quadratic equations by graphing. So what they have, for instance, I'm going to give you a little example. The very first one, I want you to solve 1a and 2a. 1a gives you the quadratic function, and it gives you a chart on the side, right? It gives you an x, and it gives you actual x coordinates, 1, 2, 3, 4, and it wants you to fill in the y's by solving it. I want you to do this the faster way. That's the long way. I want you guys to factor this, get your x-intercepts, and then graph the parabola. Okay? There's a graph on that page. This will be much faster than solving it the other way. I want you guys to try that now. I'll give you a little bit of time. Division